Hey, Anna from NHCSR here. The United States Department of Agriculture recently funded a research project through their Specialty Crops Research Initiative Program, SCRI, that will investigate integrated pest management of corn earworm. Now, corn earworm is a key pest of several vegetable crops like sweet corn, and it has some devastating economic impacts. There's a very impressive team here of integrated pest management specialists, crop production specialists, economists. This was a big investment in your tax dollars by the USDA. And even though this is a brand new project, we're already starting to see results from this team, which is very cool and really highlights the importance of programs like that Specialty Crops Research Initiative that fund big teams of people. They are ready to hit the ground running, and they're able to replicate experiments across broad geographic ranges so they can get a lot done really quickly. Expect to hear more from me about the results of this project because I think it's really interesting. I want to summarize two papers from this team, take a look at some baseline stuff, and it gives a really nice summary of why this system is so important. First and foremost, sweet corn is very different from field corn. Sweet corn is a vegetable that people eat. Field corn is a grain that animals eat. So we all know that cows are vegetarians, but they will not turn up their snouts at some corn with a few caterpillars in their food. This does not bother them. This is not a major issue. This is not the case for people. Finding a caterpillar in an ear of sweet corn is a severe enough tragedy for many that it would maybe make you not go back to the farm stand if you found one in an ear of sweet corn from there. Or at least that is the fear that's keeping your local farmer up at night and guiding some of their decisions. What makes the situation worse is that these bugs are literally falling out of the sky. Moths will migrate from southern areas up through the mid-Atlantic and the Northeast. They're landing on corn plants. They're laying eggs on corn plant. Those eggs are hatching and the worms are boring their way down into that vegetable. So there really isn't too much a farmer can do to avoid this other than applying preventative insecticides. So are they just out there spraying every day? No, certainly not. Because we have IPM tools to monitor the activity of the moth. We can go out there, see if they're active, see if the corn is actually at risk of infestation, and make those insecticide choices based on risk, right? So you're really only applying insecticide when it's absolutely necessary. This is a really cool system. It works pretty well. Farmers save time and money. They use less pesticide. We're all happy about that. And we all benefit from having sweet corn without any caterpillars in it. But technology progresses, biology changes. There's some shifts in behavioral change of the moth, migratory patterns. We also have invented new IPM tools. We're not just spraying vegetables with neurotoxins nimbly-bimbly the same way that we were when this whole system was first developed several decades ago. So the experts on this team have decided that it is well time to reassess this approach. These papers start at the absolute beginning and make some nitty-gritty assessments of the current monitoring techniques to test some of the assumptions that we think are true but we're not quite sure about. Here are three of the most commonly used traps. All of them are baited with a lure, an attractive pheromone lure. The lure is just a little hunk of plastic or rubber. They load a synthetic version of the female-produced sex pheromone. This is attractive to male moths. So this is important. The female moths are the ones that are laying the eggs. They're the ones causing the damage. Male moths aren't bothering anybody. They are just looking for some action, right? But they give us a really good idea of how much moth activity is happening in your neighborhood. The two traps on the top, the lure is placed at the opening at the bottom. So those males that are looking for the ladies underneath the trap, and whoops, they fly up and they are captured at the top where they are later counted by the IPM professional, usually on a weekly basis. The bucket trap below them, the opening is at the top, and we kind of hope they fall into the bucket below where they'll be counted later. We usually put a little vapor strip, a little kill strip loaded with insecticide in that bucket. It'll intoxicate the moths enough and it helps knock them out and get them to fall into the bucket. Now, something that we suspect is that the heart stack trap, the wire one, We think this does the best job at capturing moths, or at least it always captures the largest number of moths. This is confirmed in this study. The first round of experiments this paper presents the mean percent total of moths captured per night, and there's a significant difference between all three trap designs. Heartstack are trapping a lot more moths. So why would you use the inferior trap? Those wire traps, they are kind of a pain to transport, to store, and you have to make them yourself, right? You can't buy them anywhere. This white one here on the right, we call it a Heliothis trap. You can buy these. They fold down, they're easy to clean, you can store them between seasons. And this is the same for the green bucket trap, which takes up even less space, but you're just not getting the right bang for your buck. So a lot of people like this Heliothis trap. And going forward, I think this team wants to work with this trap because it's the easiest, it's everybody's favorite. But why is there such a difference between these two traps? It looks like they work pretty much the same. Better sensitivity is obviously valuable, especially for early detection in low density populations at the beginning of the season, and it'll enable better, more timely management decisions. They also want to make sure that the data mean the same thing no matter what trap you're using, right? So if one researcher or one farmer is using one trap up here and another farmer is using a different trap over here, like, do those numbers mean the same thing or do they mean something different? So catching 5 moths versus 25 moths will come out with very different spray recommendations. But if those differences are predictable, they can adjust those recommendations accordingly. So what's the difference? Why is there such a big difference? Authors suspect that the answer is a pretty simple one. The size of the hole in the bottom. There's a difference, right? If you look at this up here, this is the bottom diameter of the Heartstack and the Sentry Heliothis trap and the original one. And what they did was they modified that Heartstack trap to have the same size opening. That's all they did. They did a head-to-head study to see if they could catch the same number of moths, if the holes were the same size. Bingo, bango, no significant difference. That was pretty much it. Now, because there are multiple suppliers of both traps and of those lures with the pheromone on it, and because the investigators couldn't quite decide on just one lure type for this study, everybody kind of had their favorite, they ran this experiment with all of the top 4 major lure types and found something a little surprising. Even though they all contain the same chemical, more or less, the synthetic sex pheromone we're talking about, they got different results. Hercon trapping significantly more moths than Alpha Sense Trace. Authors speculate that this difference might be as simple as the Hercon lure material. So like that little hunk of plastic that the pheromone was loaded on, that the pheromone will evaporate differently depending on what that is made of, the shape of it, also some other things, environmental conditions, temperature, humidity, vapor pressure. Well, we don't have to speculate too long because the second paper I wanted to cover took a closer look at the differences between these lures from all the major suppliers. Here's the lures they were looking at, and I think there should be a big attaboy to these companies. They did not have to share this information. They did not have to participate in this study. So I think it's very cool that they were so open about this. A big thank you to those collaborators. Here you see the 4 different lures. The pheromone blends are slightly different, dispenser types are different, and the amount of pheromone that's initially loaded on each one varies. So the first question authors asked was how much pheromone was released from the lures over time. This figure shows work that was just done in the lab under consistent environmental conditions. So they found that more pheromone was released from Hercon and Sentry lures and the other lure types for the first 2 weeks of aging. Then they continued to release just as much pheromone as other lure types until the end of that aging study. So if you remember, Hercon lures had a lot less pheromone loaded onto those laminated polymer dispensers. Well, Sentry just starts out with a lot more pheromone than the other lures. I think it was 5 milligrams versus 2.5 or 3 milligrams. This pattern was observed again when they replicated this aging study in the field. So using these lures in traps, they measured how many moths were captured as the lure aged, and you see that average proportion of total moths caught per night, kind of matching the same pattern that we saw in the evaporation rate. This explains most of the differences they found. So authors conclude that emission rates, not the original concentration inside the lure, are associated with lure performance. Historically, this has been kind of a non-issue because most folks who are maintaining these traps, be it a farmer, be it an extension professional or a crop consultant, they're going out there to check those traps at least once a week, if not more often. So the idea of replacing lures every couple of weeks has been kind of a non-issue. Expensive part of these lures is the pheromone after all, so it doesn't really make much of a difference in price. But, it would be easier not to have to change the lures all the time and carry them out to the field. So a whole lot of work, a whole lot of trapping here just to answer what ended up being pretty intuitive questions. But now we know, and this team is able to proceed knowing these things to be true and supported by the data. I cannot wait to find out what happens next. Thank you for listening.